Hello and welcome to the 181 video on hierarchical agglomerative clustering. So hierarchical agglomerative clustering is another way of solving the clustering problem, so it's sort of an alternative to k-means. And the main way that it's different is k-means is a type of algorithm that we would call divisive clustering. So it's top-down, you say we think they're going to be k clusters, and then you try and divide the data up into k parts, looking at everything sort of as a whole. Agglomerative clustering is another approach where we start at the bottom at the individual data points and we try to build clusters from pairing things together and then slowly building the clusters up, almost a bottom-up approach. So it's a little bit different way of clustering. So how are we going to do this? First, we're going to start each data point in its own cluster, and then we're going to repeat the following two steps n-1 times. First, we're going to measure the distance between all clusters. I put distance in quotation marks because it's unclear which distance we'll be using, and actually we can use lots of different distances and they'll give us slightly different results. And then we're going to merge the two closest clusters and record the distance that they were apart in something called a dendrogram, which will let us demonstrate the hierarchy. That's where hierarchical comes from. And I'll talk a little bit more about the dendrogram later. But we're going to repeat this n-1 times, which means that overall, all the data points will eventually get into one cluster. So what are some distance metrics that we can use? Four common ones are, first, min linkage. So if we were looking at a cluster C and a cluster C prime, then we take the minimum over all possible pairs of data points of the distance between them. So this says, get the two data points with the minimum distance between these two clusters and then use that as the distance. We can use max linkage, which is very similar, but we're going to take the maximum. So we're going to look at all the possible data point pairs, and we're going to look at the maximum distance between them, between two clusters. We can take average linkage, which is just the average over all possible pairs of data points in the two clusters. Or we can take the centroid linkage, which is the distance between the two center points of the clusters. And these are all fair ways of doing clustering, and if you use different ones, you'll get different results. So for example, here, if you use min linkage, you'll often get more stringy clusters because it will just go ahead and grab the nearest data point. Whereas if you use something like max linkage, then you'll get more sort of cohesive clusters. So another difference that we might have is here, if we use a min linkage classifier, we might get data sets like one around this inner circle right here, and then one on the outer circle. But if we use something like average linkage, then we're more likely to sort of split this into two parts. So this is not to say that one distance metric is better or worse than any of the others, but just that they perform differently in different scenarios, and that's an important thing to keep in mind. So last thing that I wanted to do is do an actual example of a hierarchical agglomerative cluster. So let's say we have these data points, -2, 1, 2, 9, and 12. Obviously, they could be in higher dimensions, but it's just a lot easier if I only use one dimension. So the first thing that we do is we calculate the distances between all of these, and right now the clusters are just singular points, and our first join will be between 1 and 2, and that's going to have a distance of 1. So we'll use this little diagram to denote that. And now, let's say we're using the min linkage criterion. So the distance between 9 and 12 is 3, and the distance between the cluster containing 1 and 2 and -2 is also 3. So it doesn't really matter which one we do next. So we'll do 9 and 12 here. And here, they are a distance of 3 apart, so we can denote that. And then now we're going to connect -2 to the cluster 1 and 2, and they're a distance of 3 apart. And now there are only two clusters, so we'll connect these, and they're a distance of 7 apart. And we would generally make the sort of heights of these bars approximately proportional to the actual distances between those points. So this is why we call it a hierarchical agglomerative clustering, is because we end up with this hierarchical model that shows us what our groups are. And this makes it really easy. In k-means, I have to specify the number of clusters that I want beforehand, but for hierarchical agglomerative clustering, I can just run it once, and let's say I want 2 clusters. Well, then I'll break this, and I will just have a cluster of -2, 1, 2, and then another cluster of 9 and 12. Or if I want 3 clusters, then I'll break this, and I have 3 clusters of -2, and then 1 and 2, and then 9 and 12. So you only have to run it once, and then you can look at breaking it up into different cluster sizes. So that can be an advantage of this clustering method.